Thanks for joining us today. This little chat is on behalf of the Landscape Ontario's Plant Symposium. It's going to be held on February 3rd in Fanshawe College in London, Ontario. And today's talk is going to be on plant health and soil management.
I'm Bob Reeves from a company called Root Rescue Environmental Products, and we have a specialization, a niche market that we try to serve. We have a product called Root Rescue Transplanter, which is mycorrhizal inoculum. Now that's maybe a mouthful for some folks because that's even hard to pronounce maybe, but mycorrhizal fungi are a key part of normal health in soils and normal health of plants, and they're often missing in urban and suburban soils because of high disturbance of soils. The whole trick is to help the plants recover and the soil recover from the construction process and to leave things in good shape. And that's where inoculum like ours comes into play.
What's the importance of living soil and then supporting that mycorrhizal network?
Right. Well, again, I think I'm going to take a shot here and see if I can't show a slide. I don't mean to sort of take over the party, but a lot of this microbial world is hard to imagine, especially if someone's listening to this who says, "What, Micah? Who?" You know, it's like, what's this crazy guy talking about? So I'm going to try to share screen here and see if I can be successful. See if I can bring up my screen.
So, Jaleesa, have you allowed Bob the ability to share? Oh, there we go. Awesome.
Okay, so good things are happening. So, here's the PowerPoint slide that I wanted to bring up. I've got a couple here. I'm not by no means going to nail you guys with this monstrous PowerPoint. That's not on. But what I wanted to show was this, and this is this amazing diagram of the trophic levels of life in healthy soil. And it starts out here at the top with this little bird just trying to make a living eating worms. And the question that is answered by this diagram with its layers and its massive numbers is, what does it take in the soil to provide enough earthworms, snails, and slugs to feed this one little bird? And the answer is all of these things are part of living soil, all the way from the top of the pyramid where things are quite large, such as earthworms, and we can see them, insects and myriapods and diplurians and spiders and so on. And then things get progressively smaller and more numerous, and everything is making its way. It's finding its lunch. It's moving through the soil, finding things to do. And critically, it's also creating waste. But at the bottom of the pyramid of life in soil, and this is the thing, all food chains have a bottom. And the bottom of the pyramid of life in soil is fungi and bacteria. And that is the one part of the soil system that plants feed directly. And that is really the important thing. Think about plants. I was asked, and Jocelyn suggested it as well, is that plants are like the orchestra leader. They tell everybody exactly what they're going to do next and provide direction for all. And the orchestra leader in the health of soil are the plants themselves. And for this simple reason, plants have this amazing ability to photosynthesize, to turn sunlight, CO2, and water into sugar. And they are the only living things in the universe that we know that can do this. And it's an absolutely amazing biological skill. What do they do with that sugar? They use some of it to grow their bodies, to grow more cells, to flower, to fruit, to get bigger and taller and stronger. But a huge percentage of the sugar that's created in the leaves by photosynthesis is piped down into the ground and fed to selected microbes. They don't just give it away willy-nilly. They feed particular communities. And one of the communities they feed are these specialized fungi called mycorrhizae. And that is at the bottom of the pyramid. And the mycorrhizae, the specialized fungi that can only make a living by talking to plant roots, by making connection with plant roots, that's where they're sustained. They're sustained by the sugar that comes from photosynthesis. And sugar, what is it? It's a simple carbon compound, creating a carbon compound critically. The CO2, the carbon in CO2 is integrated into the glucose. It becomes part of it, and it's now pumped down into the ground. Jocelyn was speaking about this earlier. We got to sequester carbon. Well, it's pulled from the atmosphere by photosynthesis and pumped down into the ground and fed to bacteria and particular bacterial communities and fungal communities. And they just go about their business. And the fungi are paid to extract water and nutrients from the soil. They go after the parent material that's there. They look for phosphorus in rocks and minerals. They turn it into P2O5 and pump it right back into the plant. That's how plants get their minerals. After all, plants are amazing organisms, but they're in the end very simple. They can't digest anything themselves. They don't have a gut. They have no stomach. The way the simplest animal, an amoeba, has a stomach, it's got a gut. It can digest things. That's what makes it an animal. The plants don't. They have to hire professionals. And they do this digestive work by paying organisms like bacteria and fungi to digest things for them. Feed them sugar, they will digest things. And that foundational arrangement at the bottom of this food chain of life in soil is how everything works. Once you've got that foundation built, the protozoa move in, the nematodes move in, the mites move in, they all start to build this amazing pyramid. There's so many billions of them just feeding this one little bird that the larger ones act like rototillers, and they aerate the soil, and oxygen can go lower now. It's an amazing dynamo that once it's started, it runs itself as long as you don't screw around with it too much. But the important thing is to get the bacteria and the fungi at the bottom of that pyramid in place so plants can make the connection to them and feed them and get fed by them, and everything else starts to turn. The magical wheel goes round and round, all driven by sunlight and photosynthesis. It's an amazing system. So this is what mycorrhiza do. They're essentially both a physical connection to the soil. They extract things from the soil on behalf of their plant host and feed the boss. They feed the plant every day. What they convert, what they mineralize, phosphorus, potassium, calcium, chrome, everything, copper, the small amounts of every metal that plants need in their cells, and there's more and more small amounts of everything that the plants need are found every day. They're all extracted by mycorrhizal fungi and bacteria just by converting what is there already. For instance, the need for phosphorus in our soils is really overemphasized by industry. You don't need to apply bone meal to anything. What you need are the microbes that, in fact, their job is to convert the abundant phosphorus that's in our native soils, in the sand, in the gravel, in the clay, and give that converted phosphorus to the plant. That's their job. It's what they're paid to do. They're paid the sugar meal to do this. And so it's the foundational bit, and everything else happens because they're in place. And so that's really what I say to people who are, well, how do I get the wheel of life started in soil? Start at the bottom of the pyramid. Make sure that the bacterial organisms that are key are in there. Make sure the fungi that are key are in there. The plant will engage them because that's how its system works. And then once they're engaged, everything else starts to improve and starts to build up and take care of itself. In the ornamental plant industry, which is the industry I grew up in, what happens is plants under a system like this, plants grow at the rate at which they can get what they need from soils. And if you've got an organism like mycorrhizal fungi and beneficial bacteria, PGPR fungi as they're called, serving the role of extracting the needed nutrients from the material in the soil, then the plants will grow at exactly the rate at which the organisms in soil are feeding them. They start to lock in. They don't grow too fast and wilt back in the summer. They don't grow too slow. They grow exactly at the rate at which they're designed to grow at optimal health. And that's the other thing about chemistry. It tends to goose plants into a false growth cycle. They get soft and flabby and grow too big and too fast. And whereas in a natural cycle like this, or a natural system like this, where you're growing plants not with chemistry, but with biology, plants adapt instantly to the available resources and grow at that rate, at the optimal rate they can grow. Everything starts to work exactly as it should. So what else have I got here? Yeah, so these guys are doing this thing. The plants, why do plants need these things while they're living? Well, while they're living, they're doing all the work of extracting nutrients and converting things. But even when they're dead, all of these organisms in their millions are extremely valuable because they improve the CEC capacity of soil, the cation exchange capacity of soil when they're dead. They turn into that brown humus substance, humic acids and fulvics and so on. At the end of their, can't break them down anymore, or they're dead. And what do they turn into? They turn into batteries for the soil that hold the volatile nutrients like nitrogen, which desperately just wants to turn back into a stupid gas and float away. It's the cation exchange capacity of soil, the dead things now turned into humus that act like a battery. So this mountain of living things is what soil life actually is. You don't have to know that. What you have to know is if you put the bottom of the pyramid in place, it starts to run itself. It's just not any more complicated than that.
And you mentioned phosphorus, Bob, and I was talking with a friend who's also a grower, and he was saying that likely in 30 years we're going to run out of commercially available phosphorus.
Well, the good
What's the
news,
nursery industry going to do when it's gone?
David, as a result of that same thing, the ice age that we mentioned earlier, vis-a-vis the peat bogs, that very same ice age, that mountain of ice, 1.5 miles thick on its way to Ohio all those years ago, ground all our rocks and soil. And by the way, pushed all the topsoil from that era down into Ohio. It's 200 feet thick down there. They were gifted all our topsoil. But all that grinding of all that ice, because ice sheets don't stay still, they move. And this was giant grinding machine, ground up everything underneath the ice sheet into finer and finer particles. And every rock native to the igneous rocks in Canada, the things that are in the Canadian Shield, are full of phosphorus. They're full of potassium, they're full of nickel, they're full of calcium. And by grinding them into finer and finer particles, they're more biologically available. They're easier for microbes to find. I mean, if you got a rock this big, I can get things out of the outside of it. I smash it into a billion pieces, same weight, same mass, but it's infinitely more available. What's hidden in it can now be found. And we were gifted that by the last ice age. So this idea that we'll run out of phosphorus is absurd. It's under our feet. What you need are living microbes whose job it is to go out there, find that mineral phosphorus, turn it into P2O5, the useful form of it that plants can use in their cells, and pipe it into the plants. Think about a forest. It's perfectly healthy and happy with nobody fertilizing. I mean, there's enough bird shit in the world to get that much phosphorus. You've got to get it from the parent material. You've got to get it from the rocks underneath the forest. And that's the job of the microbes. That's the job of the mycorrhizal fungi and the beneficial bacteria, the stuff that's in Jocelyn's formulations. They're just working at solubilizing those mineral things that are in the parent material in soil. And so that's a myth that we're going to run out. What we're going to run out of is the easy kind, the kind you can reach a bag and throw it in the ground. Instead, get your professionals to do it. Get your mycorrhizal fungi and your bacteria to do what they've known how to do for hundreds of millions of years, which is to give plants the phosphorus they need by extracting it from the parent material in soil. That's the simple truth. You don't need to install phosphorus today. You don't need to phosphate fertilize today. It's already there.
Well, that's my understanding. Everything we need, the plants need, is there. They just have to be able to access it. And it doesn't matter if it's nitrogen or phosphorus or potassium. It's there. They just have to access it.
Well, the nitrogen is funny. I mean, what's the output of all those things I showed you in that giant pyramid? They all take a dump. You know, they're all living and creating waste. And then they ultimately die. So they create ammonia, this amazing chemical, which in too strong a concentration is deadly. I mean, I don't need to tell you. Want to take a whiff of some, you'll know what I mean. It's really pretty bad stuff. And with that many things living in that little amount of soil, why isn't the soil instantly toxic with ammonia? The answer is the bacteria that Jocelyn has in her formulation, they think ammonia is lunch. And they attack it because they've been trained to think that's how they make a living, to eat ammonia, and they convert it into nitrate and nitrate and nitrite. That's their job. The thing they're really good at is eating waste products of life. Eating the stuff that comes out of the back end of everybody else is their lunch. So the more waste there is, those populations explode because their lunch is now laid out for them. And that turns into nitrogen. And that nitrogen that's how the nitrogen, it's very volatile, ends up in the plants. It's a kind of on-demand system. When plants need nitrogen, the bacteria crank up and they create it and it's produced. It's not vaporizing into the air and turning back into N2 gas, which of course is in abundance in our atmosphere. What, 78% of the air we're breathing right now is nitrogen. It just loves to be a lazy N2 gas. But if you can grab it and turn it into get the bacteria involved, they can sequester it and make it available for plants. And that's the nitrogen source. Nitrogen, after all, is a gas. Phosphorus is a rock. Somehow plants need all of these things. Some of them are gases, some of them are rocks. And yet the microbes, no problem. I can do that. I can make the necessary conversion for you, and I can feed you what you need. By the way, it'd be nice if you fed me. Plants can do this. They've got all that sugar. And that's the amazing cycle of it. You know, they've got this a magical currency called glucose, which is produced in their leaves. And they use it to full effect. They use it to buy whatever they need, the services of whomever they need. And that's how the system fires.